Hi everyone, in this lesson you're going to be learning about how to divide polynomials. And there's two methods. There's long division and there's synthetic division. And we're going to try both and I'll be curious to see which one you like better. So the first one we're going to look at is polynomial long division. And it's just similar to numerical long division. And so I'm demonstrating them side by side here. Just like numerical long division, we have a divisor. We're dividing that into our dividend. We're going to get a quotient, and then sometimes we will have a remainder. So we have our polynomial here. We have our divisor being divided into it. We're getting our quotient, and in this example, I don't have a remainder. All right, so you can use polynomial long division to determine if a divisor is a factor of a polynomial. So let's look at this first one. We're going to set it up. And what you want to do is you want to look at this very first part of the binomial, the first term in the binomial. And we want to see what would we multiply that by to get the first term in what we're dividing into. So x times what gives me x cubed? Well, x squared times x, so x squared times x is going to result in x cubed. Now you can't just ignore the 1 there, so we're going to do x squared times x to get x cubed, and then x squared times 1 gives me x squared. So we're going to put plus x squared. And just like in numerical long division, what we're going to do now is we're going to subtract x cubed plus x squared from the polynomial that we're dividing into. Now the way I like to handle that is I just change the signs and add them together. So we have a minus, and then I think of it as adding together instead of subtracting. That seems to save me some mistakes. So x cubed minus x cubed gives me 0, and 2x squared minus x squared gives me x squared. And then we'll bring down the minus 5 and the minus 6, just like we would in numerical long division. Now we're going to repeat that process. What times x gives me x squared? Well, that would be x. So x times x gives me x squared. And then x times 1 gives me x. I like to think of it as just doing a sign change and then adding them together. So I'm just going to put a note above each one what the sign change is and then add them together. So I have x squared, and I'm adding it to a minus x squared, that gives me 0, minus 5x, minus x, that gives me minus 6x. And then bring down the minus 6. Repeat the process. So x times what is going to give me minus 6x? That would be minus 6. Minus 6 times x gives me minus 6x. Minus 6 times 1 gives me minus 6. Do a sign change. Add them together. We get a remainder of 0. So our solution for this, we get a quotient of x squared plus x minus 6. And then we have to answer the question, is this divisor a factor? Since we don't get a remainder, it is a factor. So yes, x plus 1 is a factor. Now, if you got a little confused, you may want to just watch me do that process again before we turn the page and do some more practice. We're going to repeat that process with 5 problems on this page. If you feel like you're ready, try them on your own and come back and restart the video and check your answers. So for each polynomial, we're going to divide by the given divisor, and then we're going to determine if the divisor is a factor of the polynomial. So first, we'll set it up. And we want to determine what times x is going to give me x squared, and that would be x. So x times x is x squared. And then x times negative 3 is negative 3x. Do a sign change. Add them together. And then bring down the minus 12. X times what gives me 6x? That would be plus 6. So 6 times x gives me 6x. And 6 times negative 3 gives me negative 18. Do a sign change. And we end up with 6. Negative 12 plus 18 is 6. So we have a remainder of 6. So my answer, my quotient, is x plus 6 with a remainder of 6. And I know that x minus 3 is not a factor. All right, let's do number 2. Set it up. X times what gives me 3x squared? That would be 3x. And then 3x times negative 4 would be negative 12x. Sign change. Add them together. Bring down the minus 4. X times what gives me x? Well, just times 1. 1 times x is x. 1 times negative 4 is negative 4. Sign change. We get a remainder of 0 in this case. So the answer, the quotient, 3x plus 1. We don't have to write remainder 0. If you want to, you can. And we're going to say that x minus 4 is a factor. Okay, number 3, set it up. 3x times what gives me 15x squared? That would be 5x. And 5x times 1 is 5x. Sign change. Add them together. Bring down the minus 2. 3x times what gives me negative 6x? That would be negative 2. And negative 2 times 1 gives me negative 2. Sign change. And we get an answer of 0, final remainder of 0. So we know that our solution is 5x minus 2. Our quotient is 5x minus 2. And we know that 3x plus 1 is a factor. Okay, 2 more. Hopefully you're starting to feel pretty good about these. So we're going to set it up. All right, x times what gives me x cubed? That would be x squared. And then x squared times 3 gives me 3x squared. Sign change. We get 0. Bring down the minus 4x and bring down the minus 12. I'm going to erase that 0. I don't really need that there. What times x gives me negative 4x? That would be minus 4. And then minus 4 times 3 gives me minus 12. Sign change. It gives me a remainder of 0. So our solution is x squared minus 4, and that means x plus 3 is a factor. And our last one, all right, x times what gives me x cubed? That would be x squared. And then x squared times 4 gives me 4x squared. Do a sign change. And we get minus x squared. Bring down the 6, the minus 6x, and the minus 8. What times x gives me minus x squared? That would be minus x. And then minus x times 4, minus 4x. sign change. And we're left with minus 2x, bring down the minus 8. And what times x gives me minus 2x? That would be minus 2. And minus 2 times 4 is minus 8. Do a sign change. I get a remainder of 0. So my quotient in this case is x squared minus x minus 2. And since my remainder is 0, I know that x plus 4 is a factor. All right, hopefully you feel really good about those right about now, so let's move on. All right, now we're going to look at synthetic division. And when you first see someone do synthetic division, it seems a little crazy, a little overwhelming, but trust me, I think you're gonna really like it a lot better than long division. And the primary reason is it's just a shortcut method. I mean, here's an example of using long division versus using synthetic division for the exact same problem. Now, it only works in the special case of dividing by a linear factor. So you just have to keep that in mind. And let me demonstrate here in an example of how we do synthetic division, and I'll demonstrate it over and over in this lesson, but these are the steps. The first thing that you do is you write down the coefficients of the dividends. So 2, 6, and 29, 2, 6, and 29. You're going to leave placeholders where you're missing a term. So notice this goes from x cubed to x squared, and the x to the first term is missing. You're going to put a 0 in as a placeholder. You're going to change the sign of the constant in the divisor. So if we have x plus 4, we're going to put minus 4 in the little box in that top left corner. We're going to bring down the first coefficient. We're going to then multiply that coefficient by what's in the box, and then add together. Multiply, put it here, add together, multiply, put it here, add together. The answer is the sequence of coefficients of the new polynomial, but it's going to be 1 degree less than the original polynomial. So this polynomial that we started with was cubic. When we reduce it, we're going to now get a quadratic. The last term would be the remainder. If the remainder is not 0, put that over the divisor. Or you could certainly say remainder -3. But usually, when we do these kinds of problems, we'll write it that way. So you're probably feeling like totally confused right now, but don't worry. Trust me, 2 or 3 times of watching me do this, you're going to start to love it. I kind of miss teaching this live because it's really fun. All right, so let me repeat the process. First thing we're going to do is we're going to take that x plus 1, and I'm going to put -1 in the box. That's because I have x plus 1 here, and the opposite of 1 is going to be -1. The opposite sign of 1 is -1. That's what goes in the box. And then I'm going to take all the coefficients. I have 3, -4, I have 2, and I have -1. And I'm not missing any terms. It goes x cubed, x squared, x to the first, and a constant, so I don't need 0 as a placeholder. So let me write down my coefficients. 3, -4, 2, and -1. All right, we're rolling here. First thing you're going to do is you're going to bring down that 3. Then you're going to take that 3 and you're going to multiply it by what's in the box. 3 times -1 is -3. Now we're going to add these two guys together. We get -7. We're going to take -7 times -1 and put it here. -7 times -1 is 7. Now we're going to add these two guys together. We're going to get 9. Now we're going to take 9 times -1, and that gives me -9. And again, we're going to add these two guys together, and that gives me -10. So my final solution here, and we're all done, since we started with a cubic, this first term is going to be 3x squared. So we're going to have 3x squared minus 7x plus 9. And we have a remainder of -10, so we're going to do -10 over x plus 1. Done. I think that's a lot quicker than using long division. Let's try another one. So we are dividing by x minus 2. So that means that positive 2 is what's going to go in the box. The coefficients are 1, negative 11, 38, and minus 40. We're going to bring down the 1. That's the first part. Now we're going to do 1 times 2. That gives me 2. It goes right here. Now we're going to add these two guys together. That gives me negative 9. Negative 9 times 2, that gives me negative 18. It goes right there. Add these two guys together, that gives me 20. And then 20 times 2 gives me 40, goes right there. Add these two guys together, and that gives me 0. Now, whenever I get a remainder of 0, I put a little smiley face because that just makes me really happy. That means that x minus 2 is a factor. And what's our reduced polynomial now? Well, we started at x to the third, so this first term is going to be x squared. We're going to reduce it by 1. So we're going to have 1x squared minus 9x plus 20. Oh, it's so fun. I hope you're enjoying this. All right. Hopefully you're feeling ready to try number 3 on your own. Go ahead and do that. When you're ready, come back. Dividing by x plus 1. So we're going to put negative 1 in the box. Our coefficients are 1, 4, 1, and negative 6. Bring down the 1. Then we're going to do 1 times negative 1 is negative 1. That goes there. Add them together. 4 minus 1 is going to give me 3. 3 times negative 1 is negative 3. Add these two guys together. I get negative 2. Negative 2 times negative 1 gives me 2. It goes there. And I get a remainder of negative 4 because negative 6 plus 2 is negative 4. We started with a cubic polynomial, so we're reducing it by 1, so it becomes 1x squared plus 3x minus 2 with the remainder of 4 over x plus 1. All right. Number 4, we're given a polynomial. We're asked to use synthetic division to divide by x plus 2, so let's do that first. We're going to put negative 2 in the box. Our coefficients are 1, negative 2, negative 5, and 6. Bring down the 1. 1 times negative 2 is negative 2. Negative 2 minus 2 is negative 4. Negative 4 times negative 2 is positive 8. Negative 5 plus 8 gives me 3. 3 times negative 2 gives me negative 6. And 6 minus 6 gives me 0. Little smiley face, no remainder. We started with a cubic polynomial. We're now at a quadratic, so we have 1x squared minus 4x plus 3. All right, so far so good. It says use the answer from part A to completely factor the polynomial. So we already know that we have one factor that is working for us. That's the x plus 2. That's one of the factors. And we've reduced our cubic polynomial to this guy, so we just have to factor that now to know the other factors. So if we factor that, we're going to get x minus 3 and x minus 1. So all the factors of this polynomial, part C, is x plus 2, x minus 3, and x minus 1. All right, that's it for number 4. Now, synthetic division is generally used for finding zeros or roots of polynomials. We have this thing called the remainder theorem. P of A is the remainder of a polynomial divided by the factor x minus a. So if P of A equals 0, if the remainder is equal to 0, then we know that x minus A is a factor. So this sort of just puts into words what we've been practicing all through the lesson. So it says we have an example here. We're being asked to check P of negative 2. So it's saying P of negative 2 is the remainder of a polynomial divided by x plus 2. Find P of negative 2 and help determine if x plus 2 is a factor. All right, so we're going to put negative 2 in the box. Now this time they're telling us that x plus 2 is the factor, put negative 2 in the box. So P of negative 2 is, and then we're going to list all our coefficients. Now be careful here because we're missing some terms, so we're going to need some placeholders. We have x to the 5th, so that means we'd put a 3, but we're missing the 4, x to the 4th, and x to the 3rd term, so I'm going to need to put 2 zeros in as placeholders for them. Then the x squared term, the coefficient is minus 8. The x to the first term, the coefficient is minus 1, right? We have minus 8, minus 1, and then minus 5. All right, so let's do synthetic division. We bring down the 3. 3 times negative 2 is negative 6. Add them together. Negative 6 times negative 2 is 12. 0 plus 12 is 12. 12 times negative 2 is negative 24. Negative 8 minus 24 is negative 32. Negative 32 times negative 2 is going to be 64. Negative 1 plus 64 is 63. 63 times negative 2 is negative 126. And negative 5 minus 126 is 131. Since we got a remainder, the remainder is not 0, we know that x plus 2 is not a factor. We're going to do some practice for each of the following. Find P of A and then determine if x minus A is a factor of the polynomial. So we're going to put negative 4 in the box. We're going to write out our coefficients. That would be 1. Now we're missing the cubic term here. We go from x to the 4th to minus 5x squared. We should have a cubic term. If we don't, we have to put a 0 in as a placeholder. Then the x squared coefficient is negative 5. The x to the first coefficient is 4, and our constant is 12. Use synthetic division, bring down the 1. 1 times negative 4 is negative 4. 0 minus 4 is negative 4. Negative 4 times negative 4 is 16. Negative 5 plus 16 is 11. 11 times negative 4 is negative 44. 4 minus 44 is minus 40. Minus 4 times minus 40 is 160. And we get a remainder here of 172. So P of negative 4 is equal to 172. That means that x minus a negative 4 or x plus 4, that means that is not a factor. Okay, 2 more to try. We're going to put 3 in the box. List our coefficients. Bring down the 2. 2 times 3 is 6. Negative 5 plus 6 is 1. 1 times 3 is 3. Negative 8 plus 3 is negative 5. Negative 5 times 3 is negative 15. Add them together. Ooh, we get 0 as a remainder. So we know that x minus 3 is a factor. Last one, put negative 1 in the box. List out our coefficients. We have 2, 6, negative 5. We're missing the x to the first term, so there'll be a 0 there, and then minus 60. Bring down the 2. 2 times negative 1 is negative 2. 6 minus 2 is 4. 4 times negative 1 is negative 4. Negative 5 minus 4 is negative 9. Negative 9 times negative 1 is 9. 0 plus 9 is 9. 9 times negative 1 is negative 9. We get a remainder of negative 69. So we know that P of negative 1 is equal to negative 69, which means we got a remainder. Therefore, we know that x minus negative 1, or the factor x plus 1, is not a factor. All right, everyone, that's all I have for this lesson. I hope you enjoyed it. This was a fun lesson for me. All right, I look forward to hearing your opinion now on which do you like better, long division or synthetic division. All right, have a great day.